if we look at the two parts, the algae, the fungi, what is each one bringing to the table that benefits the other?
hmm I think in a lot of associations it varies to some extent, but in the kind of the big picture, the algae produces the carbohydrates or foods, and the fungi produces the housing or protection for the organism. And
See,
the algae needs protection because one, it'll either dry up and die, or two, some invertebrate will come along and eat it. And the lichen is able to um, afford it protection from desiccation because it'll dry out and make a like a protective coating of it. And often those fungi have antibacterial properties. So things like penicillin is an example of a fungi producing antibacterial. And then, and in like World War II, they didn't have penicillin. They used this chemical called usnic acid, and they harvested usnic acid from lichens,
hmm.
and that was the universal antibiotic. So 50, 60 years ago, lichens were a much bigger deal in medicine because they were antibacterial.
If we look at one part of it, algae, I'm assuming most people know what algae is, but I think when people think of algae, they think of it in association with a body of water. It's in a
Yeah.
pond, it's in a lake.
Mm-hmm.
How much of algae the species, maybe that's not the right term, but when you look at algae as a group, how many are more terrestrial based and don't live in bodies of water?
Yeah. Not that many. Most algae are require more moisture.
So you have this unique algae that it's out of the norm and it
Mm-hmm.
finds a spot like, hey, I want to live here. It forms a relationship with this fungi to perform to become a lichen, and they exchange carbohydrates for protection.
Mm-hmm.
So the algae is producing carbohydrates through photosynthesis. How is the fungi protecting it while still allowing it to photosynthesize? If you're, it's not like, is it clear? Like making it almost like a glass?
It actually will act more like a sunscreen because a lot of times what's damaging for free living algae are the UV lights and the intensity of the light. So it's uh, the fungi tends to provide uh, protection from sunburning, so to speak. And the fungi often becomes more pigmented when it's in full sun versus partial shade. So some fungi will look somewhat green when they're in the shade of a tree. When they're at the tips of the branches, they will be more orange colored and produce more pigment. And their goal is to provide the perfect greenhouse for the algae. They don't want it too bright, just like the three bears. They don't want it too bright, too dark, just right. And that's what the lichen kind of does. And then it physically protects those algal cells from uh, invertebrates, insects, or other organisms that might eat them.
Because it's unpalatable to those
Or
insects.
uh, either that or just physically separates it. You know, when it's dried up and it's got this fungal material there with a few, often with some chemicals in it that make it less palatable. They'll still eat it sometimes, like slugs and snails will eat lichens. Some insects will eat them, but not a lot of them. And they can also physically exist better as a lichenized unit rather than as separate lichen, fungi, and algae.
Is the fungi mining any of the support structure that it's on for minerals? Obviously, if it's on a metal signpost, I don't think it's
Mm-hmm.
breaking that down. But if it's on the side of a tree, is it going into
It
that bark, pulling anything out of it?
generally it's thought that it does not. There are a few exceptions to that. Like I mentioned, there's one lichen, and maybe because it's not economically important, they haven't pursued it or tried to discover, but it tends to only occur in rotten wood. So I assume it's getting something from the rotten wood. But we don't really know that it's getting any phosphates or anything like that.